Welcome again to the Advantech Technical Training. We will continue with the second part of the Common Field Site Device Introduction. Now, we will introduce you the devices that are more commonly used in automation field such as Electrical and Control Cabinets, PLC, HMI, Power Generation, Controllers CNC. The electrical cabinet. It has the function of support for mounting electrical or electronic equipment such as switches, measurement elements, displays, etc. Protect the contents from the environment such as water, dust, corrosion, etc. Prevent electrical shock to the operators during their work. The electrical cabinets are manufactured with different materials: stainless steel, aluminum, polycarbonate, fiberglass. Its performance is based on the IEC 60529 standard that classifies the ingress protection rating, IP codes, of this cabinets. This standard IEC 60529 classifies the degrees of protection provided against the intrusion of solid objects and water in electrical cabinets. The standard aims to provide users more detailed information than vague marketing terms such as waterproof. Ratings are defined by the letters IP followed by 2 digits. The first digit is related to the protection against ingress of solids. The number indicate conformity with the conditions summarized in the tables below. For instance, the number 0 means there is no protection, and the number 6 means protection against the ingress of dust tight. For example, an electrical cabinet rated with IP2X is protected against a solid greater 12.5 mm diameter, which can be fingers and they will not be damaged. The second digit is related to the protection against ingress of water. The number indicate conformity with the conditions summarized in the table below. Thus, the number 0 means there is no protection, and the number 7 means protection against submersion at 1 m depth. For example, a cellular phone rated at IP67 is dust resistant and can be immersed in 1 m of water for up to 30 minutes. Electrical control panels are designed for mounting control mechanical equipment. Usually the design of a cabinet starts with 1. Incoming protection and switching. 2. Power and energy monitoring and control. 3. Power distribution system. 4. Thermal management. 5. Motion and drivers. 6. Circuit and load protection. 5. Motor control. 8. Enclosures. 9. Power supplies and transformers. 10. Programmable controllers. 11. Operator dialog. 12. Interface and I/O. 13. Machine safety. 14. Relays. External elements of an electrical cabinet. 1. HMI panels is a graphical interface that allows information exchange and communication between machines and the operator. 2. A push-button switch allows to turn on and off a machine. When it's on, a small metal spring inside makes contact with 2 wires, allowing electricity to flow. 3. Maintained push buttons. They require to be pushed once and can keep the stay until is pushed them. 4. Emergency stop switch is a safety mechanism used to shut off machinery in an emergency situation. 5. Tower lights, shows the state of a process, alerting that some process happening. Internal elements of an electrical cabinet. Inside a cabinet, can be found several electrical devices. Some of them are introduced as follows. 1. Transformers, they are used to convert one AC voltage to another AC voltage. Most popularly would be converting 480 volts AC to 120 volts AC for creating control power. 2. Programmable Logic Controller (PLC) is the brain of the control panel. It reads inputs and trigger outputs, then adjust the outputs of the control panel. 3. DC Power Supply converts AC or DC to a DC voltage. Most commonly converts 120 volts AC to 24 volts DC. 4. Ethernet switch is used for connecting the devices such as PLCs, HMIs, and integrate them into the same network. 5. Circuit breaker protects loads from pulling too much current and help to prevent a possible damage to the whole system. 6. Disconnect switch. It will usually disconnect all electrical power from the control panel. 7. Wire duct is usually ran around the perimeter of the panel and in between rows of electrical components. Wire duct house the wires that interconnect the electrical components. 8. Terminal blocks are connection points to tie wires together. Some are for internal connections and some are for connecting field components to terminal blocks. 9. Breakout boards are specialized terminal blocks that can be used to simplify wiring of components that have connectors that would normally need soldering. 10. Fuses are like circuit breakers and protect loads from pulling too much current but are only good for one use, cannot be reused. 11. Relays is an electronically or magnetically operated switch. Power is applied to the coil, and it switches the relay contacts. As a result, the contact that was open at the beginning will change the status, and turn to be closed. 12. DIN rail is a metal rail that allows the mounting of many industrial control components. 13. Overload protects loads, usually motors, from pulling more current than the overload. 14. Contactor is the same as a relay but is usually larger in size and used for a 3-phases motor. An application of this is a motor starter, which helps to switch the power automatically or manually to a motor and at the same time protect the motor from overload or faults. A programmable logic controller, PLC, is a computer designed to work in an industrial environment. It continuously monitors the status of devices connected as inputs. Based upon a user-written program, stored in the memory, it controls the status of the devices connected in the output. PLCs are used in many machines, in many industries. Typically employed in industrial electromechanical processes, such as control of machinery on factory assembly lines, amusement rides, or light fines, amusement rides, or light fixtures. The PLC mainly has 5 parts: input module, output module, CPU, and power supply. The primary function of a PLC's input circuitry is to convert the signals provided by these various switches and sensors into logic signals that can be used by the CPU. The CPU evaluates the status of inputs, outputs, and other variables as it executes a stored program. The CPU then sends signals to update the status of outputs.